Hello and welcome to the online course Easy Geosteering. Here we break down the main geosteering aspects into easy-to-follow steps, presenting them in a clear and logical way. We are currently in the second part of the course, BHA components, and in the previous lesson we covered neutron density logging. And today we will explore blind sensor zone and most common BHA types. Let's get started. So, we have already come across this definition. The blind sensor zone is the distance from the sensor to the bit. The sensor allows us to determine whether we are inside the pay zone or not. However, we cannot be certain about what happens ahead between the sensor and the bit. That's why in video number 5 we refer to blind zone as one of the main uncertainties in the geosteering process, and the smaller the distance, the better. Since each sensor is positioned at a specific location, it also has its own distance to the bit. Let's take a look at an example of a triple combi service in real time. The bottom of the well is at 40-60 meters MD. The last gamma ray measurement is 12 meters above the bottom. The resistivity is 17 meters, density 20 meters, and porosity 22 meters. Also pay attention to the last vertical track, which shows the rate of penetration. Unlike other measurements, ROP is based on the draw work surface sensor, and it is recorded directly at the bit, meaning it has no blind zone. And sometimes ROP can be linked to the reservoir flag. For example, when drilling through sandstone at a high speed, a decrease in ROP may indicate that the bit is encountering shale or a non-reservoir formation. Next point, the blind zone depends on the specific tool design. For example, here resistivity measurement has a 17 meters, but a tool from a different manufacturer may have a different distance. And finally, the tool position in BHA plays a role also. Of course, the drill bit and RSS have fixed positions in the lower part of the BHA. Also, neutron density tool has its permanent position in the upper part. But telemetry, resistivity and other tools can be arranged in different orders in the middle section, depending on customer requirements. Okay, let's consider some common BHA types with different tools. In video number 10, we explore the three main types of mud pulse telemetry, and here we will apply the same classification. The first option is a mud motor with slow telemetry. It provides only gamma ray and DNI, and these measurements are taken far from the bit, around 20 meters. Because this is the cheapest setup, it is widely used in many projects for both landing and horizontal sections. The second option is a mud motor with fast telemetry, which also includes resistivity measurements. This telemetry tool is a hybrid between MLWD and LWD, making it a versatile downhole equipment with lower blind zone, about 15 meters. The high bit rate allows us to get gamma ray, DNI, resistivity, and all the necessary steerable data points. Point number 3 is a rotary steerable system with minimum real-time data, only gamma ray and DNI. Since RSS requires more steerable data than a mud motor, it can be used only with fast telemetry tools. As we mentioned before, RSS has its own DNI and gamma ray on board, which gives it the lowest blind zone, about 2 meters, and this is incredibly useful for geosteering. For the main gamma ray measurement, we still rely on the curve from telemetry tool, which is about 10 meters from the bit. However, RSS gamma ray generally matches LWD data, which is why they can be used for geosteering decisions. And the last type is triple combo with a rotary steerable system. This setup allows for drilling long horizontal wells with a comprehensive set of LWD curves. In some cases, these curves are sufficient for formation evaluation, eliminating the need for wireline service afterward. At the top of BHA, there is a neutron density tool with a blind zone of approximately 20 meters. This tool cannot be placed closer to the bit than the telemetry tool, as the natural gamma ray measurement would be strongly affected by the radioactive source. Additionally, some tools are designed with an extractable source, allowing it to be retrieved through efficient operations in the event of a stuck pipe. Alright, we have covered sensors blind zone, the most common BHA types, and finished the second part of the course, BHA components. In the next lesson we will continue with the third part of the course, geosteering tools. So stay tuned and give this video a thumbs up. See you in the next lesson. Bye bye.